that, there is the engagements through corporate affairs. Those are the numbers directly to the environmental department. However, you're also welcome to engage with corporate affairs, and they will convey whatever complaints we get from us as well. Sorry, I just wait until you move, then I... Okay, so to start off, this is just a bit of a background. So as I said, there's the two platforms that we usually receive complaints through, either on the cell phone, via call or WhatsApp, or then the email address. We need to capture the details of the complainant, like the telephone number and the name. We try to keep the personal details to the minimum, and that personal details are also not shared further than that. So, for example, we need to report the complaints also to the authorities, but when we report the complaints to the authorities, we do not report the personal information of the complainant, without permission in any case. So, when a complainant calls us, it is important to get as much information as possible. In terms of the relevant information, it's absolutely critical that we know the time during which the smell occurred. And the reason for that is that our ambient conditions in Secunda changes quite frequently. So the time period during which the smell occurred will give us an idea of the wind direction and the general ambient conditions during which the event happened, and that will assist us ultimately in determining whether the smell originated from sasol or somewhere else, and hopefully we'll get to it, hopefully give us a bit more guidance in terms of where in sasol it actually occurred. The other aspect is to give us as good a description of the smell as possible. I know it's sometimes difficult because not everybody in the community works or has worked in a chemical facility, and they're not that familiar with all of the different smells that you can get there. But as good as you possibly can, describe the smell, because that will also help us to pinpoint the area in the plant from which such a source could have originated. We obviously need the location as well, because the location is important when we look at the wind directions. For that purposes, we don't necessarily need the exact address, but we need to know the neighborhood from which the complaint originated. Step 2, as I've alluded to, that is first off looking at the ambient and weather data. So that data will give us a view on the wind direction. And the first thing we look at, complaint was received, was the wind blowing from the factory in the direction from where the complaint was received. It means there is likely factory that resulted in that complaint. If you know what to look for, you can identify them in that ambient monitoring data. But I'll get to that a little bit later. The screening and dispersion thing in the ambient data that indicates it could have originated from the plant. So now we need to determine exactly where in the plant and factory, and we found out from them whether there was any upsets that occurred, because usually when you have odor complaints, you can relate it back to an upset condition on the factory, something abnormal. To the next step where you go try and identify the plants that could possibly have contributed to it, and you go drill down into a deeper investigation to determine what happened in those specific plants. And that's actually what we had to do in this investigation. Then once we've landed on a possible source of emissions, then we need to provide feedback. We've completed the root cause analysis. We've identified the corrective and preventative measures that we're going to implement to avoid such, meaning the accuracy and quality of the data has been vetted independently, and they can be used as reference actually for calibrating. As a limited amount of them. We have the one here at the club, That's the only one in Secunda town that we have. Then we have one at Bosjesspruit in the Bosjesspruit direction, and then we have a station in Imbalenhle South and Imbalenhle North, which is in Imbalenhle itself. In addition to those, the South African Weather Service is what's happened in the Imbalenhle area. We also have a monitoring station in Leandra. Because Leandra is also part of several occasions. We use the data from that Springs station to assess what contribution, if any, sasol made to the complaints that we received from that area. Do we have?
It's just lost connection.
This is unfortunate. But okay, let's maybe pause here while we have to pause here. Any questions thus far? You can see the boundary here in purple. That's the boundary of the secondary area, and then the factory here in the middle. So it is quite a large area that I think you guys are all familiar with. The message I want to convey here is really around the wind directions. So for this specific instance, now this is just an example. It is not what actually happened during the complaints that we received. This is just an example. So what happened at the time that we took the snapshot, the screenshot, the wind was blowing from the club towards sasol. So normally you would say, okay, that means if it was blowing from town towards sasol, then sasol cannot be responsible for any complaint. The source of odor must be somewhere else. But what's also interesting is that if you go and look at the different weather stations in the factory, you'll see that some of them are pointing towards town. So they are not all pointing in the same direction. As a matter of fact, if you look at that, the direction's kind of all over the place. So ultimately, what do you say? What's the direction that the wind blowing? You have that from Sasol Club. You have something that is almost in the opposite direction, at least in one of the weather stations in the plant. The reason why it looks like that, and there's a number of reasons, it's actually very seldom that the wind blows in a straight direction. You normally get cyclical wind patterns. So it moves in cyclone type of forms. Sometimes those cyclones are very large, so that in essence from where you sit, it is basically a straight line, because it's a very large type of motion. Otherwise it's actually some other times it's quite small. So you can see the circulation of air even over the town where you live. That's the one element. The other element is vegetation, geographic location, large and tall buildings and structures. All of that interferes with the wind direction. If you have a tall building that's directly in the path of the wind, you are going to see a different type of trend from what you would have otherwise seen on a plain savanna grassland. So there's different interferences from that can influence the wind direction, but mostly this what you're seeing here would be because of the cyclical movement of air over the plant. The other thing to consider as well is that the air movement at ground level is not the same as the air movement at elevation. You can even see sometimes at the main stack that the plume goes in completely different direction from the wind that you feel here in town. So just in terms of assessing the ambient conditions, that makes it quite difficult, especially if this is the only information that you have to go on. Which means that just from looking at the club data, the only thing that you really can say is it looks like the wind was blowing in this direction. That's the only thing you can say. Should it be the other way around and that needle points towards the town, then you can see, okay, the wind came from the factory towards the town, but that doesn't help you at all to try and indicate where in the plant the problem is. That problem can be anywhere in the plant. You're unable to narrow it down. Which means that, sure, in the case that there was a big upset on the plant, then it's easy. You know, this upset happened, and you can say this is what contributed to it. But in the case where there's no such a big upset condition, you actually now need to go through all the different plants that could contribute and try and narrow down what caused this now. Which means it's an extensive task. And in essence, that's what we needed to do with the complaints that we received in April and May. If we go to the next slide.
Sorry, Hannes, what is the impact of the main wind direction? Because obviously this is now current eddies that you have in the area, but the main wind direction would be in a specific direction. What I mean is, like, if you look at windy.com or one of those applications, it shows the larger high pressure and low pressure systems and what the wind direction is overall. Does that not have an impact, or is the impact of this greater than? Even
with windy, you can see, like I said, it depends on exactly how large the movement of air is.
Yeah, but I'm
so
saying,
even with windy, you can see it going in circles.
Yes, yeah, but I'm saying is, if you look at that, then you can see what the main direction in a smaller geographical location is. What have you found? Does this have a greater impact?
I'll answer your question just now.
Okay. But this is actual, right?
This
I know this is actual, but I'm saying if you zoom out a bit, you're going to see that despite this, you can have a wind direction in a predominant direction.
It's also not exactly as straightforward as that.
Yeah,
because the eddies have an impact. It deflects the, let's call it plume.
Yeah.
It deflects the plume a bit, but I'll answer that question. So this is the type of information we had available when we received the complaints in April and May. So, and as Rex also indicated, it is possible to go and identify a source, but not with the information we have here. If we then have to go and determine exactly what the source is, you would need to buy data from NASA to give an accurate indication of what the weather patterns was, and then you need to do the modeling. And the screen is actually not even adequate. You're going to have to go and do more detailed dispersion modeling to really confirm exactly where it came from. So an exercise like that takes very long, especially given the uncertainty that you have with complaints. Because normally with complaints, you cannot say exactly what the composition is of the complaint, of the substance that was causing it. You can also not exactly say what the volume is. So without having that, it is very difficult even with the modeling. But we have found a way of resolving that problem, and we'll get to that now. This is just a typical trend that we get from the ambient monitoring station. We mentioned that at the monitoring stations we are recording certain pollutants, and one of the first things we do is to go and look at the ambient monitoring station to see which pollutants have reacted in a way that's unexpected or is looking like outliers during the same period where we experienced the odor event. So this is just an example. It's not again specific to the time period, and this is for PM10, and it's on a daily average basis. So usually with complaints, we will not look at a daily average, we'll look at an hourly average to start off with. The other thing is, sasol produces a lot more chemical components and different components than we measure at these ambient monitoring stations. So one of the first things we do is the one at the club, for example, it measures the particulate matter, it measures sulfur dioxide, it measures nitrogen oxide, it measures hydrogen sulfide. So if you look at those trends, if it's emissions from our main stack that has an impact here, you will see the sulfur dioxide going up, you'll see the particulate matter going up, you'll see the NOx going up, not necessarily in the same form, but you will see there's an upward trend on all of them, and you will see the hydrogen sulfide moving up. So if you see all of that, you know this is coming from sasol. If you see the sulfur dioxide, the PM, and the NOx going up, but not the hydrogen sulfide, it means that it's coming from Tutuka power station there, because that's also the other area that could affect it. So like I said, you kind of have a fingerprint. If you see these components trending, you know it's the main stack from sasol that's contributing to it. We also have ammonia measurements at the sasol club. The ammonia measurement will give you an indication of changes in ammonia concentration in at the club itself. But again, the issue with ammonia is some people are very sensitive to ammonia, so they can start smelling it even at very low concentrations. And the lower the concentration, the less accurate the analyzer is in terms of picking it up. So there is an analyzer there, and it can be used to at least indicate if there is changes in the ambient ammonia concentration. We'll go to the next slide. That's just sulfur dioxide. Oh, maybe, sorry, go back. That's just for interest sake. So this trend that you see, this is now over a whole year. So this trend that you see with the peaks and troughs, we see that in all of our stations, and we see it every year. So it basically gives you an idea of the impact or the conditions during the different seasons, and the impact that those conditions during the different seasons have on the air quality. From sasol side, if you look at it over an extended period of time, the emissions from sasol is more or less constant. So it will not show you that variability. The reason you see that variability is in springtime you have a lot of agricultural activity, so there's some dust from the agricultural activities that contribute to it. Before springtime, you usually, in the winter time, you actually have a lot of veld fires happening that contributes, but also you have a lot of, let's say, solid fuel combustion for heating and cooking purposes. Especially the guys that lives in Sunset Park can attest to that smoke that hangs over the whole area, and that's basically from solid fuel combustion for heating and cooking purposes that occurs. Obviously, that's not the only factor. If you're talking about that smoke that hangs there, there's also an inversion layer. So during the winter months, you have an inversion layer that's fairly low, meaning the emissions that originates at ground level gets trapped underneath that layer, and that also results in the ambient air quality deteriorating. But that's just for interest. We move on to the next slide. Next one. Again, you guys are familiar with sasol, so this is just a high-level flow diagram of the different units that we have, and all of these units are producing different chemical components, and from an odor perspective, those chemical components can all have a different smell. So, like I said, one of the things that we try to do with the descriptions that we receive during complaints is to try and narrow down the area where chemical components that could have a smell like that is located. That at least gives us an idea of where to focus the investigation. Now, I've referred to improvements that we've made. Previously, I mentioned around the challenges we have with the wind direction and establishing exactly where the source of the odor is given the movement of air. And Rex also asked the question of, isn't there something that we can do to actually allow you to see what the predominant direction is and what would have been. So we have implemented a new environmental information management system. So all of the data of all of our monitoring stations, including the weather stations, is captured here. It also has an additional functionality. The modeling part that I mentioned previously, that modeling part is now built into it. So it's automated to an extent. And with that, you can, I think if you go to the next slide, with that you can do something like this. So you can, and this is what we call a back trajectory. So what we do here, this is an actual example, by the way. So it's something that we received a complaint in the Crane Park area here. So we wanted to see, okay, where did it originate? And you can see it actually goes there and then it kind of levels out. It's almost like an S-curve that it follows. But ultimately, it crosses the factory here. Now this white and purple line that you see here, that's the likely area from which the source originated. However, it is possible that the source could also be anywhere in this band. And that's for two reasons. The one is there is obviously the cyclical movement from the wind that creates a bit of uncertainty. As I said previously, the presence of buildings and the geographic layout of the land, all of that also have an impact. Plus, you get dispersion. So as you move further away from the source, you get some dispersion happening of the pollutants. And that must also be taken into consideration. So all of that means that although this line is the most likely area, you cannot completely rule out the rest. So the downside of it is it's not always this bad. Sometimes that whole purple band is a lot narrower than this one, which means that you can narrow it down a lot better. In this case, if you look at the entire purple band, it still is most of the factory. However, if you look at the one where it's most likely, you can see it crosses the API dams there. So the API dams is one of the areas that we know can be a source of odors, possibly. So in this instance, that will be where we start our investigation. It doesn't mean that the API dams was the source, but because that line crosses there, and because we know from history that APIs can be a possible source, we start our investigation there. So using this tool, it allows us to be more focused in our investigation, to narrow down the field, and then hopefully get to an answer a lot quicker and a lot sooner. So what we did, and this is now specifically around the complaints that we received in April, May, and June relating this characteristic. So what we did, through again the weather, the assessing the ambient conditions, some of the complaints were ruled out. There was a little bit less than half of the complaints was during periods where the wind direction was actually blowing away from the factory. So they were ruled out, but there still was a large number of complaints left for periods where the wind was blowing from the factory towards the town. So the focus of the investigation was narrowed down to those complaints. If you look at those complaints, there was a lot of different descriptions of the odor that people experienced. We received very frequent references, even on social media you'll see that cat urine was a popular complaint from people. Now, fortunately I don't have cats, so I'm not entirely sure what cat urine smells like. But we Googled it and we found some idea of what components in cat urine actually causes the smell. And from there, we were able to say, okay, these types of components can possibly come from these units. And that's what we did there. The other one was a sweet sulfurous smell. So again, we work with sulfur and we know which areas in the plant can possibly have components with a sulfurous odor. So we'll focus on that area. The other one, which was very specific, was around how. So, and this is where we are privileged, because we have people that live in Secunda and that worked in that area and that actually knows what how smells like. So we don't always get as good a tip as that. So that means that we knew we had to go and focus in the how area. So focusing in the how area doesn't necessarily mean that that we immediately know what's going on. As a lot of you know, there was some process changes made to the how. In essence, because of our requirements to be compliant with the MES, we decommissioned our how incinerators. So they are no longer running, meaning what went there in the past is no longer going to the incinerators, is no longer being incinerated. What we did there is we split the old house stream into different components. So there is what's called the Fenisolvan house stream. That Fenisolvan house stream is still going to water recovery, where it is then mixed with reaction water, sorry, where it's then mixed with reaction water before going into the dams itself. So yes, it is possible, although we didn't expect it, it is possible that there could be smells originating from that mixing and feeding it into the biobasins. So that was investigated, and we had our R&D colleagues going there with sniffers and gas detectors to see if there's a problem. That was actually where we started. But at that point we confirmed that there's actually not anything really coming out of that portion of the process. It's not the only portion of the process. So the remainder of the how that used to be part of the how, that is now sent to a storage tank where for further processing, and ultimately it's now being sold as fuel wood. So we upgrade it and we sell it as fuel wood, the other portion of it. So that portion, at that time of the complaints, all of it was actually in the tank. So you wouldn't expect that to be the source of the odor because it was contained in the tank. It wasn't at that time being processed any further. Plus, the descriptions that we got from community members, like I said, was very specific. So the smell that was described to us was more the type of smell that you would expect from Fenisolvan than anything else. So we needed to go and look at, okay, we know it's that. We know that even from people on the plant, they complain from time to time that they have that smell. So something must be going on there. We, together with the plant and technical support, then had an extensive investigation into the process. And from there, we found a number of issues at the house tanks, which I'll get to in the next slide. So, like I said, the house tanks, that was kind of an obvious one because we had people that were able to specify that that's exactly the odor. For the rest of the complaints, we couldn't really narrow that down further. There was ammonia. Some people said it was ammonia. Some people said cat urine, like I said, but cat urine also has a component of ammonia in there, so we cannot rule that out. The API dams, as I mentioned previously, it's one of the suspects that we need to consider, and that we know it's a source of possible emissions. And then obviously the mainstays. The bulk of our emissions come from our mainstays, so we always need to look at that. So that's the plants and the areas that we ultimately identified as the most likely sources of these complaints. If we go to the next slide, and here's now a bit more about the findings. On the API dams, what we found there, now again, this didn't necessarily all happen at the same time, and we can also not say that any one of them was the sole source. As a matter of fact, the complaints is mostly a result of a combination of these factors rather than a single one. And that's probably also why we got such a number of different reports in terms of the smell that people smell. So on the API dams, we found that there was a TSV, a temperature safety valve, that is in the pipe rack, and that was actually leaking into a sump. And that sump was then drained into the API system. So for some reason it went on for a while before it was actually detected. So I must say it is in a pipe rack, and it's not located in an area that's immediately obvious, but it took much longer than what we want, what we would expect to pick up that leaking valve. However, it was, we did determine that that's a source, and we obviously fixed it, and the maintenance strategy is revised to ensure that that doesn't recur, that there's frequent inspections. The feedback I got from the plant there was that the material that's going through the pipe there actually causes some blockages in the valve. It becomes sticky, and that is what they expect resulted in the valve then leaking. But as I say, the maintenance strategy has been revised, and that issue is resolved. With the hull tanks, and this is now the most interesting one, we found, as I said, we investigated the whole mixing system, where we mix it with the strip gas, with the reaction water. One was stuck on strip gas liquor. Where we mix it with the reaction water and it goes into the dam, so that's where we started and eliminated it. But ultimately we ended up with the hull tank itself. So when we looked at the hull tank, we found two problems. The first one was with the hatch on top of the tank. So that hatch failed and was open for a long period of time, and obviously emissions from that tank could then go into the atmosphere, and depending on your ambient conditions, it will either settle down towards the plant itself, or it could be carried towards town. And that's where the dispersion modeling comes in actually. So you wouldn't normally expect the tank is relatively low. So you wouldn't normally expect for a piece of equipment that's so low to have such a big impact in town. So we had to do some dispersion modeling to assess a worst case scenario. So if we assume the worst case scenario in terms of what's possible to get out of that tank, as well as the worst case scenario for ambient conditions, we confirmed that yes, theoretically it is possible that this can contribute to smells in the community. The other factor there obviously is that the components present is also the type of components that causes odor even at very, very low concentrations. So you do not need a lot of it to actually cause a odor problem. So that was the one problem. The other problem is the hatch was then replaced and was fixed. That was sorted out. Then after that was done, we again got some complaints that was very similar to what we had previously. So in terms of those complaints, we again went back to the tank and we looked at what's happening there. Then we found that the pressure control system around that tank was not operating properly. So there's portions where it worked fine, but then there was other portions where it was completely out of control and it basically vented the emissions from the tank into atmosphere. So that we found, and currently the engineers are busy correcting that issue. It's something that we've only recently landed on, and it's being addressed. We're looking at design changes there to improve the control of the pressure of that tank, specifically the nitrogen blanketing system around there. The other one is around our strip gas liquid cooling towers. And this is something that's also a first for me. I never expected them to be a problem. So what happens is, that comes from phenolphthalein. So what happens there is, if there's an upset at phenolphthalein, and the type of upset that we're talking about is usually because of an issue with the LP steam, where the effectiveness of the stripper column there is impacted. if that happens, then you see the pH in the strip gas liquor increasing, and you see the ammonia concentration in the strip gas liquor increasing. So that then goes to the cooling towers. Because you have the high pH and because you have high concentration of ammonia, in essence that ammonia is degassed in the cooling towers, and it's released from that cooling towers. So we did the modeling, and from the modeling side we also confirmed that that can indeed have an impact on the community in terms of ammonia smells and others. So what we've done there is, like I said, nobody really expected that to be a problem in the past, but once we've identified it, there has now been additional control measures implemented at the Fenner-Solvent site to proactively identify this problem when upsets happen that causes the pH to increase and the ammonia concentration to increase. And if that is picked up on the Fenner-Solvent side, they will take action, which in essence means they'll have to cut back the plant in order to prevent that from happening. So this is the areas that we've identified as being responsible for the majority of the complaints, if not necessarily all of the complaints that we've received. Well, I'll stop here if there's any questions.
This how tanks, is it new tanks or is it the old ones?
It is the old ones. They have been,
TP115s.
yeah, they have been repurposed, even not significantly repurposed, but because they're now basically being used as buffer tanks, the operation of those tanks have changed, and that means the control system had to be redesigned and adapted. Although the guys that can actually tell you more are sitting here. So there's, from an operational perspective, the tanks are still the same tanks, but from an operational perspective, there has been changes there.
The inspection edge, that's the one on the side.
It's the one on top of the vessel.
That explosion valve is edges on the side of the tank, if I'm
No,
right.
so the edge we're referring to here is the mechanical protection system on top of the tank.
That specific thing, when I was there was scheduled maintenance every 3 or 6 months for that thing. So somewhere that fell off the table and then got stuck somewhere. I mean, that was a problem in the past as well. As well as that pressure system. That thing was checked once a week, the nitrogen blanket from the instrument department and the analyzer guys. They know their operation to go check it. That was a very, very tricky thing to operate.
And it looks like it still is.
So it's not so new. It's been coming a long time. And just the cooling towers, is that the CT101s on 52s? Yes. Because that is forced draft. Yeah. And that certain gas heater is like 90 odd degrees, yes. Right? So that fan's going, I can't remember what was the volume that was going through.
So we evaporate around 200 cubes an hour.
Yeah. So if there's ammonia in that strip gas heater, that will escape like a cat out of a mouse trap.
It's a pH.
And that's the role of the pH, because if the pH is low enough, it will remain in solution.
And that was also a thing, even when I was on ships, many moons ago, we had to check very regularly with the Fenner-Solvents to see what's the ammonia, what's the pHs, and then the corrective steps. So that's also not that new. That's
what the operations also told us.
Yeah.
So, but the part that was strange was operations actually have gas detectors in that area to give them an indication if the ammonia is high. But those gas detectors didn't pick anything up during that period. So that was the problem. So we needed, and this is where the modeling comes in, we needed to go and look, is there a scenario where the emissions from that cooling tower will lift not people down into the plant area immediately, but would lift and moved more towards the town. So again, without knowing exactly what happened at that time, we cannot say with certainty, but given the outcome of the modeling, we can determine that it is a possible scenario for that to happen.
What we also found many moons ago in the age of Western, that splash trace inside the cooling towers. when last were they checked and replaced? Because if they deteriorate, if they fall, if they break to pieces, they lose their efficiency. So instead of, I'm not that clever, there's many people who think going on in there, but I can remember.
Yeah, but Kobus, what we can say is that they do maintenance per module on those cooling towers very regularly. Switch off the cooling tower completely.
Yeah.
They just switch off a module and then they look at repairs and fan conditions.
But that's the same with meter. You take A or B or C.
Exactly.
Do that.
Well, they still do that very regularly.
Okay. So that if that is maintained, that can help you a lot to eliminate drift.
No, it will definitely, and the most important part for me is the control at Venezuela. If the strip gas leaker is within the spec, within the what you call the service level agreement there, then there shouldn't be a problem in any case. But yeah, as you can see, the plant has been experiencing quite a bit of trouble.
And the API dams is the operational still as designed, 1, 2.
Yes.
It's only storm on 3 and 4 is rainwater.
Great.
I believe.
Yeah, it's
More
still
or
the
less,
same. Yeah, so it's still the same, and we have recently installed additional VOC measurements to actually pick it up as it's coming into the system. So we have got more early detection systems in place as well.
But I can remember at times when the oily storm dams 1 and 2 was full, they can overflow to 3 and 3 can go to 4 and 4 goes to the swell. And if they are full of sludge, then you also get lots of emissions.
That's been that issue has been resolved.
So there's been a lot of work done to desludge those dams. But I mean, yes, there's been work done to improve the operations of the API dam and the capacity specifically. But the big problem is you still sit with unidentified streams that's going there that should actually not be going there. And in this case, we've identified that TSV, in that TSV should not have been able to drain to the APIs.
What product was going through that TSV?
I'll have to find out. I can't remember exactly what the product was.
I'm just thinking now, Rex and Michael, Peterson, you remember that guy?
Yes.
If he was here now, you can just tell him this and this and this, and he will go out and tell you dead ends.
Waterfiscal.
Yeah. That's right.
Sorry, what did you say with the products from in APIs?
Sorry?
The products in the APIs, the emissions from APIs, what were the issues from APIs?
This specific one was related to that TSV that drained into the sun. So the TSV, I mean, it must be closed most of the time. Only when you have...
The TSV where?
It's in the tank farm.
From tank farm, actually, into API.
It's in the tank farm on the western side.
So obviously that was going into the oily storm. And from there, that's a PC101, PC102 is pumped to the water recovery.
So this was from tank farms, it's a bit different.
No, it's from APIs itself. So it was, the final location was APIs.
Yeah.
It was potential
And
VOCs.
it actually also went...
further.
It actually went to the APIs, and then through the APIs it went into the biobasins. And in the biobasins it caused problems for the bugs, as you can imagine. And obviously the biobasins also provide a bigger surface area for evaporation.
No, but so this is not the ammonia how complaint, this is a different thing.
It's a different one. Remember the complaints that we received, there was a lot that was specific how. But there was also ones that was talking about the sweet sulfur smell, that was talking about cat urine, and that was talking about the phenolic creosote type of smell. So there was a number of different complaints, which is why we looked at more than just the out tank ultimately.
Okay, so then that comes from tank form. This, you're talking about the operating procedure that was changed, in which way? Because I can't think that operation... the SGL cooling towers.
No, the SGL cooling towers is not the cooling towers where the change was. It's on the Venezuelan side.
Yeah, I would understand what procedure should they change. Because I can't think that changing in procedure would do anything.
Not unless you actually apply the procedure.
Yeah, so if it is just operating like you should, I can understand that they didn't operate, but changing an operating procedure,
So one of the things that happened there, now I can't give you the exact details because wasn't in that RCA, but we can possibly get someone from Finesolven to provide the details. But one of the issues was, for some reason, they didn't expect the ammonia concentration to go that high. So what then happened when it went to the lab thought that they made a mistake. It cannot be the problem. So the lab actually threw away the sample and they went and they retook a sample, and when they retook the sample, the ammonia was in spec. Because we're talking about incidents here. It's not like they've been operating like that for a long time. It was an incident. So, which means that actually the concentration was that high, and that's what caused the problem. So part of the changes in operating procedure was to be able to identify when they have such high concentrations a lot sooner than what they did in this case.
They should just stick to the operating procedure they have in terms of making sure that the temperature is fine.
Yeah.
So the only thing,
basically.
Yeah. The only other thing that I can think of is if you have leaks in the waste boilers at gasification, they can also cause a problem with the steam because
yes,
of the captive.
And that's exactly what happened.
Yeah. So that's an operating procedure. Then it is making sure that you speak up when you don't get the temperatures, even if you're putting more steam to gasification to resolve that issue. And I know that that's been an issue forever and a day because people always say, no, it's not with us, it's with you. And the other guy say, no, it's not with us, it's with you.
That's exactly what happened here.
So,
Sounds so familiar.
So yeah, I think it's probably that if these issues occur, that MPI takes a lead role in ensuring and that the two plants don't try and resolve it between one another. And then obviously...
so in essence, the other thing that they're going to do now, if this happens, regardless of who's at fault, they're going to cut back. So they cut back the factory.
It's very easy to find out. Just take a condensate sample on the LP condensate coming from the waste boilers, test on the capture if it's there. It's
a problem.
Yeah, and that's been the answer always. I don't know why.
Okay.
So just maybe a question on that. Is it not possible to put in an online analyzer in the condensates? Because the issue with the condensate is not just a Finesolven issue, it is also an issue with the condensate that is polluted.
It is a problem, and I know there's currently an investigation into that issue. So they are driving it. But I don't know if they found a resolution for it yet. I just know that they are busy with it.
Just one question. In Unit 5325, after the water went through the irrigation basins, through the centers, and then it goes to CD102, and a certain portion gets pumped to the cooling towers, and the rest overflows to the dams.
Yeah.
So that is basically half-treated water going to the dams, accumulating there, and it can also create a lot of vapors and a lot of smells and a lot of methane gases in that dams. Is there still aerators running in the dams?
So we've moved away from that, so we keep a minimum liquid level on the system to actually prevent that. As soon as we expose the sludge, that's when the problem comes. So we ensure that the primary receiving dams always have a sufficient liquid level.
Really?
Good. Thanks. Thanks. If there's no further questions, and thanks, colleagues. Thanks for your time. And we really appreciate your communication of us around the orders. And as I said, if we have people that can give us specific guidance and better describe exactly the smell, that always helps for us to narrow down the field that we need to go and investigate. So thanks.
Brilliant. Congratulations and thank you for that.
It's a pleasure. Thanks. Yeah, I just hope that we are going to see less odor problems in the future. I can tell you, my wife is also complaining all the time.
I must say the last 2 weeks, 2 weeks ago, it was terrible, terrible again.
Yeah, I know.
And it was just when the rainy season started, but that is also for the past since 75. 85. If it rains,
You smell.
you
I,
get
I joked with my teammates, I asked them if I can log a complaint. No, you're absolutely correct, and that's also part of the challenge. If you see the rain coming in, then usually you also form a bit of an inversion layer, and usually it also goes hand in hand with stronger winds blowing from the plant towards it. So that actually just helps to move whatever emissions is coming from the plant towards the town. But, and if you ask me specifically the last 2 weeks, the smell that we had, there was also again the out type of smell. So I'm hoping this issue of the pressure control that we've picked up now is going to solve that problem.
I hear you talking about windy weather program. Try MSN, weather. There you get a live satellite picture of the cloud formations moving. And you can see and you can smell it. When that cloud comes from Springs direction, southwesterly, give it 2 hours, then you smell it in town. You smell that now. That is actually very nice. I like to go and sit there and watch the clouds moving. Bring the smell in, and you know, close the doors, close the windows. It's coming.
From
You get very nice.
Yeah, it's coming from this side. So southeast side. So southwest. Into a northeasterly direction.
That's one area where technology is definitely helped us.
That's a very nice weather application, MSN.
Amazing.
Yeah.
Yeah, we're also looking into low-cost centers because you can see we're limited in terms of the number of monitoring stations we have. So, and speaking of technology developments, there's been a lot of, let's say, a lot of growth in the area of low-cost sensors. Well, we call it low-cost, but it's actually still expensive, but not nearly as expensive as these ones, and they are more mobile. You can locate them easily at different areas. You don't have to build a whole shelter and infrastructure for them. So we're looking into those. We have identified, we've been testing 2 for a while now. So the idea is that we're going to buy more of them and put them also in different locations. And that will allow us to be also a bit more proactive. So when those sensors pick up that something is happening, then hopefully we can respond before it actually becomes a concern in the community.
Okay. Honest, just the last thing, knowing Cobus and Rich well, our doors are always open for them to come have a look at how we tested this at R&D, what we've done, what does our handheld meters look like, how did we test above the surface. Yeah, you're more than welcome any day. I'll take you for a personal tour.
Just arrange entrance to Charlie 1.
Yeah. Yeah, we can arrange that for you. You just tell me if you want to come. Where Rex comes and visits us, Martin comes and visits us. Nothing is secret. Maybe you see something we missed. We don't know everything, but we've really extensively tested for 2 years.
Trip down memory lane.
Yes, you're more than welcome.
Dankie vir die uitnodiging.
Anytime.
Thanks, Thomas.
Yeah, so just with regards to the next item on the agenda, I spoke to Martin now. He's still a bit in fix. He won't be able to attend, but I can speak to the topic. And we mentioned it, I think, in the previous session, what can be done with regards to the high organic waste. So when Martin started at sasol, one of the things that he had to look what was at the high organic waste. And in his investigation, what he found is there are 2 components that are actually worth quite a bit of money. That was then, around 2007, 2008. I don't know what it looks like now. So the high organic waste has a lot of pyridines, about 15-16% in it, and then also acetonitrile, which is a very good solvent. The first one they use insecticides. The acetonitrile is about a third, 33%. And then obviously a whole lot of other junk which you don't even want to look at because of it being carcinogens. But the question is is the market not such that it might be worthwhile looking at separating those components and actually selling them as products? Which then means that you don't have to burn the stuff or put it into basins so the dogs can eat. It could be products. Obviously, it's a new capital project then.
So Rex, I'll just double check what we can share, but we've done in 2021 a study on acetonitrile recovery with the CSIR, and at that time it was found not to be economically feasible, but we can share that information, I'm sure. Let's just make sure it's covered from both parties, and then we can do so.
Yeah, no, we don't need it. I think it's just something to keep somewhere on the laptop.
Yeah, we didn't.
So that
We did not check pyridides. We can go check that, but acetonitrile was not feasible.
Yeah. Maybe a combination might be feasible.
So what we've done there is, as I said, nobody really expected that to be a problem in the past, but once we've identified it,
Yeah, I actually have Martin worked with Input in 2010, just before he left. They looked at this, and it was not finalized. And then Randall Albertus and I took it up with the CSIR, and we repeated that work in 2021, but it was unfortunately.
Well, maybe if you have the pyramid, it might be something.
We can look at the combination again. Up to that.
So I think that's basically what Martin just wanted to share. It's just the things that you already did, but I mean, you already have the information in several hands in any case.
so just maybe a last comment. We are planning to have public engagements again, the normal public engagements towards the end of January, beginning of February next year. So, and leading up to that, if there's anything specifically that you guys would like us to include, just let us know. You have the contact details, so just let us know if you want us to include specifics.
I just had a question with regard to plant instability. Is it increasing? Because it looks like, from standing outside, it looks like the amount of incidents that the factory is having is...
Now currently, I mean, you can see currently we're having big problems on the West Factory. I must say, this year thus far, it's actually been going good, much better than the previous years. So there was a really, especially in 2023, there was a really bad patch that we went through. But this year it's actually overall been a lot more positive. I've seen the messages, I know there's compressors that tripped and all of that, but exactly where it started and what the root cause of this problem now is, I'm not sure. But this is the biggest upset we've had this year.
This financial year or this calendar?
Definitely this financial year, I guess for the calendar, isn't the calendar year, I guess you can
Calendar
maybe
factory
take,
off for 2 weeks.
yeah, that was the trip on the eastern side. So on the one hand, it wasn't from a production loss point of view, it was definitely bigger. But from a environmental impact point of view, it may have been less because you actually had to put down the whole factory. So you had flaring when the factory went down, and then you had flaring when it came back up again. So depending on the exact durations there, this one may be worse. I can't say exactly, but yeah. Thanks, colleagues. That's all from my side.
Yeah, we learned about the tool. Hopefully or the new modeling method that you use. It will solve many more complaints sooner.
We're hoping, and we're also still working on improving and building more functionality into that tool. And so it is expanding. It's already been very useful for us.
Yeah.